So hi all, welcome to the Multimodal Weekly webinar series hosted by the team of 12 Labs. We've been doing this for over the past about 40 weeks, so roughly 7 or 8 months or so, meeting every single Friday. We discuss a wide range of topics, from news research in multimodal AI and foundation models to, innovative application of multimodal in different verticals. Since the 12 apps also focus more on video understanding and application of video AI to different industrial application, and also have folks who are expert in video research and video engineering to come share. And then more recently, we have more like internal talks from team members who share more about tutorials and guides on using our platform and APIs. In some of the recent session, we have like speakers who use state-of-the-art, research projects like Vision Mamba and Lumiere to startup founders working on computer vision to, practitioners doing video editing, for instance. And recently we released 2 new models. Last week, we have a session to focus on Marango 2.6, which is a video foundation models for anything research. And for today's session, we'll focus on the other model that we did on our release roughly 2 weeks ago. It's called Pegasus-1 Open Beta. This is a video language model that says state-of-the-art results in different video language modeling tasks, from video summarization to video composition, as well as video question answering. So the session will be broken down into 2 tracks. In the first half, we'll have Jung, who's currently our chief research scientist, who will go over the, basically technical overview, model architecture, how we, the motivation, as well as some interesting qualitative as well as impressive quantitative results of Pegasus-1. And then in the second half of the session, our founding solution architect, Travis Couture, will showcase our general API, which is powered by the Pegasus-1 model, and some of the things that you can accomplish given this model, what you can do like on a end user application point of view. So with that, this is a quick note on the logistic. Feel free to send your question on the Zoom chat, and we also have a short Q&A session after speaker finish. Yeah, so I stopped sharing my screen, and yeah, right. Do you wanna just go ahead and present your screen and go with your presentation?
Yeah. It says that host disabled participant screen sharing.
No, sorry about that. Yeah, good shot again.
Sorry, I need to change my setting.
No worries.
I should quit and reopen the Zoom. Sorry.
Yeah, no worries.
Do you see my screen?
Yes, I can see it.
Hi, welcome to our Friday webinar. I'm Ray, and it's my pleasure to introduce the beta release of Pegasus-1. Let us look at the architecture first. The architecture of Pegasus is composed of 3 main components, which is vision encoder and video language alignment model and large language model. To simplify, let's use a metaphor. Think of the vision encoder as the eye. Vision encoder captures pixel information and extracts visual features. The vision video language alignment model acts like the optic nerve. It formats the visual data into a form that is understandable by the brain, which in our case is the language model. This brain performs logical reasoning based on the visual information and formulates the final answer. During the training, we fine-tune these components to ensure that they work in harmony. However, identifying the optimal training method is challenging. Our focus is twofold. Firstly, we aim to prevent catastrophic forgetting. We initialize with pre-trained weights for the vision encoder and language model, and the capability of each component should be preserved after the training is finished. Through extensive experimentation, we've developed strategies to maintain the pre-trained capabilities, such as selective parameter unfreezing and precise learning rate adjustments. Secondly, we address dataset limitations. Unlike the plethora of image caption pairs, like those in the Lion dataset, high-quality video caption datasets are scarce. To overcome this, we've utilized our proprietary dataset comprising over 10 million high-quality video caption pairs. These contain rich, detailed real-world descriptions, including specific names of objects. For example, this is one example. It should be annotated as Toyota Camry rather than just a car in a simple video. And specific activity names like annotated as deadlift rather than just weightlifting. Now let's shift our focus to the quantitative benchmark results. We have benchmarked Pegasus against various open source and proprietary models using the framework established in Video ChatGPT. The dataset aims to evaluate answer quality across 5 key aspects, which is correctness and detailed answer, contextual understanding, temporal understanding, and consistency in answer. Each model's response to a question is assessed with an LLM, which assigns a score ranging from 0 to 5. These scores are then averaged to provide a comprehensive evaluation. Additionally, Pegasus excels in QA benchmarks like Activity QA and Next QA. These QA datasets require an in-depth understanding of video content and fine-grained semantics. Let's move on to qualitative examples. We will look at 4 tasks. They are place detection, future event prediction, and spotting oddities, and dashcam analysis. For each example, we will look at video first, and then we will look at result answer given by Pegasus. So this is the first video. This video is taken in Tuileries Garden located in Paris near Louvre Museum. So please remember these manicured hedges and well-maintained lawns as they are referred in answer of Pegasus. So given this video, and this question specify the exact location where the video was taken, Pegasus correctly recognizes that the video was taken in Tuileries Garden, a public garden located between Louvre Museum and Place La Concorde, and it captures core visual information to get to the answer. For example, well-maintained lawns, manicured hedges, ornamental trees, and various statues. And the second video.
What the fuck, dude? What the fuck?
Then the man escapes and he continues to drive. So, given this question, what would the man do after the video ends? Pegasus answers in this way. It answers the man would continue driving on the highway, and it also captures core visual information that the video appears to be the man in the video is driving on a highway at night. This is the third video. We see a cat seemingly driving a Tesla car, which is in motion. And Pegasus, given this question, describe the unusual or atypical aspect featured in this video. Pegasus answers correctly. It captures that a cat is depicted sitting in the driver's seat of a Tesla car, and it says it's humorous and endearing illusion that it is driving the vehicle. Also, like, look at text highlighted in green. These are visual information captured by Pegasus. Cat donning a floral shirt engages with the car's steering wheel and controls. Also, Pegasus is able to capture temporal information, such as vehicle is in motion. This is the last video.
That's what brings you Flowetry with Flow.
Find coverage based on your budget today. Stay in control of your spending. Insurance and
We
your
see
wallet.
a car on fire on the side of the road. And this car can be seen in certain interval.
Get insurance based on your budget with the Name Your Price tool from.
So given this question, do you see any unusual or dangerous moment? Pegasus captures, recognizes unusual moments correctly. Smoke or dust can be seen rising from the side of the road. Also, it captures core visual information in the video. Please look at the text highlighted in green. Also, it has capabilities of OCR, of catching optical characters. For example, this text were written in the sign. Thank you. We will provide comprehensive details in our following technical report, so please stay tuned for updates, and we are open to any questions you might have.
Awesome. Thanks, Ray. Any folks who have questions, feel free to just unmute yourself and ask the question in real time.
Yeah, I had a question. You mentioned the architecture of the application. Can you expand on the middle layer a little bit? You said it was like the nervous system of the application. Can you just explain that a little bit more?
Sorry, Minjoon, Kelvin, could you?
Sure. I could probably have a comment on that. So could you go to the slide that you showed us, that one. Yeah, so I guess if you think of the video encoder as basically transformer architecture that tries to represent video in a, I would say, with good embeddings. These embeddings are independently, they're actually good embeddings, but then usually by themselves, of course, it doesn't actually have meanings in the language space, right? Or I mean, they have very weak meanings. And if you look at the language model has also inputs as embeddings, but then these language models will not have a well, natural understanding of how like videos look like. So I think conceptually, the middle layer, the video language aligned model, can be thought as how can we connect the both embedding space. So the video embedding space is what we do with the Marengo 2.6, for instance. But then on the language model side, it's originally just like a pure language model. But then once we can align those input space of language model and the output space of the video encoder, then we start to see this kind of generalization capabilities appearing, which were not, of course, possible if we actually didn't have any those kind of alignment. So the alignment can be thought as basically some sort of I'll say some layers in terms of course, the deep learning layers, right? That actually align the vision space and the language space.
Oh, okay, so you just implemented more layers for that, for those, hey, the visual encoder and the large language model to communicate with each other.
That's right. That's right. Yeah. And I just wanted to actually introduce myself too. I'm a chief scientist at Pel Labs. So yeah, Ray and the team were basically responsible for the yeah, whole development of Pegasus.
Nice, thank you.
Awesome. Eldar, you raised your hand. You want to just ask the question?
Yeah, thanks, James. Very impressive results, guys. I have a quick question on like clearly the benchmark improvements are very impressive. In terms of that quality gain, you mentioned, I quickly glanced through the report, you mentioned three main areas, right? The data set, the optimization of compute, and then the architectural, like the removing catastrophic forgetting and things like that. So in your just rough assessment, like where does the quality gain mostly come from? Is it the data set? Is it you know, the new structure, the architecture of the model? Or is it even possible to like assess that? And then on the data sets, a second question is like, how did you get this data set as a small team, like 10 million videos? Like, did you use, you know, manual labelers? Like, how did you obtain this kind of high quality data set? Thanks.
Yeah, I guess like how probably also answer this. It's just because actually I think some of the information I think we are not agreed on which information we can talk about. So I think it's probably easier for me to answer these questions about the architectures or the training mechanisms. But of course, Ray is of course fully aware of it too. So I think first of all, I think as you said, it would be good to measure the exact contribution of each factor. Here, of course, the how we resolve the catastrophic forgetting and the how the data, large data, helps us to increase accuracy. I think we haven't done really close examination, but then in general, it's like something like this. I think number one is relatively, given there are a lot of methods out there in the community, in the research community, I think number one is relatively, I think what we do, the gain that we get by the way we're doing is relatively, I think, smaller than the gain we get from the high quality data set collection. Of course, it doesn't mean that the forgetting is not an important problem, but then I think it's maybe more explored in the community that there are many methods that you can use anyways, even if you're not exactly using what we did. So I think in that sense, I think number two I would say number two is it has a higher degree of factor.
I see.
Yeah, and I think regarding the your second question, which is how we collected the data. So I think one of the reasons we could have done this is because data collection is not just about money, but I mean how much money you put into, but also it's about, well, time too, because I mean video apparently is not something that I think we can build in a short period of time. And fortunately, we're able to collect videos from the beginning of Marengo. So we began working on Marengo about 2 or 3 years ago. So although Pegasus is it's almost first time this time, like, or I would say the alpha version was released last October, but then Mariango was there since 2 years ago, so we were able to leverage that time that we already spent even before I think generative AI became quite popular. And I think we are finding ways to leverage those early starts that we fortunately made.
I see. Yeah, thanks a lot, Minjoon. And a side note, I have a cat watching this video too, and she really liked the second example. Thank you.
Yep.
Great. Any other real-time question? Pranay, you want to go ahead?
Yeah, thanks, James. Thanks for the presentation and for keeping it very short and straight to the point. That's nice. So does the transformer architecture, does it tend to align with the like kind of like this align before fusion paradigm that has seen a lot of successes in combining images and text, but now using it for, say, like videos instead of images directly? And if you want me to elaborate a little bit more, I'm happy to.
Yeah, so I think what you're asking is about how different this is, for instance, from image-based language model. Am I correct?
So there's a lot of these image-based language models, but not many of them actually do alignment across the embeddings before fusing the embeddings. A lot of times they'll do something like fusing the embeddings, or that can be as simple as concatenation, or it can be something more intricate, and then passing that through a model and then having that predict something like image text matching, or in this case it might be like video text matching, as well as like optimizing for regards to language, like masked language modeling. And so I was just wondering if in this case you also, if you tried experimenting with perhaps having the alignment phase in a different part of the architecture, like either earlier or later, or different loss functions, and how
Okay.
that affected things.
I see. I see your question now. So I think that's a very good question, because I think it's also something that we are very interested in general. So I think we try different architectures, as you said. There are several ways of aligning things, and I think one thing that we try to do is well, I think one philosophy we have is that I think there is well, of course, bad architectures that wouldn't work, but we still think that there is probably not a single best architecture in general, which means at the end, I think we, of course, we want to get the architecture right, but if we get it right, then it becomes also relatively, I think, the difference between, I think, the design choices of architectures, as actually I think many people also have seen in the transformer age, where I mean people try different variations of transformer, but they've still actually found that, well, I mean, they might improve it, but then the difference is so marginal that it's not clear if it actually really matters at the end. So I think we are sharing the similar, I would say, observations, and I would say probably, but as you said, there could be better ways to pass down the information. As you said, maybe there could be a more fusion way or more complex ways, but, and of course, due to the many reasons, we were not probably 100% outlining the exact details, but then I think, as you said, I think there could be a better ways to do things. But I think we rather wanted to focus on, okay, do we get the architecture right? Whether and do we have the best architecture?
Yeah, no, I mean the results were very nice compared to the baselines. The second question I have is I don't think really the focus of this, but of course it's going to be a important consideration that I'm sure you're all aware of and might be detailed in the technical report, and that's just the like potential privacy kinds of issues that things like being able to exactly locate where someone is based on like their outside scenarios, when that might not be something that they want, or just like in general might happen spuriously. And again, I don't think that that's really the focus of this. I think the focus of this is more so to show that like this architecture works, and it works in a better way than the baselines, more comprehensively, and it answers the questions better. But I was just wondering if you've given thought to that, or if that's like in the technical report at all. Because putting in those safeguards is hard, and people will try to break them if possible.
Yeah.
Not everyone, but you know, bad actors.
I see. So I guess you're talking about the more of the security or privacy issues. Am I correct? Or
Yeah. So just like say I'm taking a video and it so happens like my background shows a certain building that to pretty much anyone is not really unique, but to something that's been trained on a large data set in a populated area, especially in San Francisco, if I'm pointing out of pretty much any window, there's like some sort of Google Street kind of transformed view of it that would be identifying the building that is in my background from my video. And so I wouldn't want people to know,
I see.
have like
Okay.
the model infer from like where it sees the video, and I mean it sees the particular building in the background, and then from the distance and the viewpoint that I'm at, like where I'm located.
Got it. I see what your point is. So because we are showing a few examples where you could actually exactly locate I mean,
And those
well,
are public places
that's
that
true.
I think are pretty popular.
Yeah.
But just with like,
Yeah.
regardless of the data set size, if it's been trained in such a way so that it could recognize that, then it is
Yeah.
just the instant concern.
I think
that could
that's a
potentially
very,
arise.
very perfectly valid concern, I think, because as you said, well, I mean, if one trained on the street videos, then I think there's high chance that the model could be able to exactly locate where that was coming from. So, of course, it's probably not an easy task by itself too, but there is a chance of that. I guess so. In that sense, I think it's really a very interesting and also difficult privacy question, because I think people will think of it as very private information, but also some people might think that it's a Google Street video, so it's not really private for some of them. So I think there is a philosophical question to that, first of all, like whether should we consider that to be privacy or not. But if we consider it to be privacy, I mean, if the law actually says it's privacy, then probably we will need some sort of tuning. I think people do a lot of these things these days. For instance, like preference optimization, that the model refuses to answer if the question is about a very private location that is not public. So I think that's still possible too. Although I think that's very very novel, I would say, privacy problem that we haven't encountered yet. I think all those privacy problems right now are more of a I think whether the training data has privacy issues.
All right. Thanks, thanks, Minjoon. Thanks, James.
Yep. I think we're almost out of time, right?
Yeah, I wanna maybe there's also like a couple more questions I just wanna go over. I think the modern part is very important to set the context here. So this question from Dima. He asks, I noticed that Pegasus-1 now supports analyzing video as short as 5 seconds and without audio. What change in model bring these capabilities?
Yeah, I can briefly just answer this. I think, of course, Ray could too, but I guess the change is really about, I think, supporting short videos was not really an issue before too. We just we didn't actually put enough, I would say, effort to. I mean, there was I would say, if it didn't work, then we could think of it as bug rather. So supporting short video was not really an issue. Without it, audio is also not really a I would say technical problem. It's more of giving that option. So I think for now, it's not really about the technical capabilities. It's more about we actually saw a lot of customers wanting that options, so we added that. But it's not I would say new technical feature.
I hope that answers your question. Perfect. I think Abhinav got a question earlier just about like the playground limits you to 20 minutes for the Pegasus. Is the limitation of context window, or was it a soft limit that can be increased further? Since that is more like on the product side, I think Travis can quickly touch on that in his part. Yeah, any other question from the audience on the modeling capabilities, technical innovation, etc.? All right, it seems like there's not any, but if you do, feel free to just ask in the chat. Yeah, Travis, do you wanna show some cool demo of Pegasus?
Yeah, sure. I'll share my screen. Can you guys let me know when you're able to see it?
Yep, I see it.
Perfect. So all the demos I'll show today, I sort of just pre-generated live while we were, while Ray and Minjoon were presenting and answering questions, just so we don't have to wait for all the text to generate here in the case of long response. So I do want to address the first question, which is, what about the scenarios where we have a longer video? So in this particular example, we're actually looking at like a collection of Ralph Lauren ads from different time periods. So it's really just a montage of ads. But the reason I show this is you can see, right, this is 19 minutes and 58 seconds. So even for videos that have extremely sort of, longer play times, we're able to output like a coherent summary here. So for the sake of readability, it sort of breaks the video down into individual parts here. So you can link that to the different parts within the video. Of course, we also have highlights and chapters that are time coded to different segments of the video. You can see here, these are about 1 minute and 30 seconds long in most cases. We get more fine-grained descriptions for each of these tighter time windows. And on the homepage here of the Generate and Playground, we also get a high-level summary, generation of a title, and things like hashtags automatically, as well as a topic. So you can see this is the original file name here in this particular instance. And the idea is that once you sort of index the video with Pegasus, you can come to the playground and you're able to either in the UI do what I'm showing here, where we have the pre-baked templates where you can generate everything I'm showing here by default without having to put any input. And of course, this is available from the API side as well too. We give the calls for both the gist, summary, chapters, and the highlights. But arguably the more fun and more interesting side of things is where you actually start prompting the Pegasus model yourself. So you can do some fun or interesting things with this, but I did want to highlight that we can handle longer videos in the playground. I'll switch over to another example here, which is where we have Gordon Ramsay like giving his famous scrambled eggs recipe, basically. So this is a bit of a shorter video, but I just sort of wanted to show the default template here and then move over to the My Own Prompt side. So the My Own Prompt is sort of where you can come, and it's very free form, where you can provide sort of instructions or questions to Pegasus to be able to pull out the exact information you want from the video. Because as we know, video is an incredibly dense data source, and it's virtually impossible to write a full text description of everything that's occurring in the video. So typically having some type of prompting to help target what you're interested in is very powerful. Even humans need this, right? So the famous example I like to give is, if you think about the scene where the college students are passing the volleyball back and forth, and it asks you to count how many times it's been passed, you count it, and then it gets to the end of the video and it says, did you notice the dancing gorilla or dancing polar bear, depending on the version that you want? And even as humans, almost every human misses that because you've been prompted to look somewhere else, and there's so much visual information, even the human brain can't really process it all at once. So that's the same concept here with Pegasus. If we want to pull something specific out, we want to prompt it. So in this particular case, I'm going to start with something that seems simple, actually, but is really not because it's sort of motion based. And this is where the temporal aspect really comes into play, analyzing video temporally and not as a series of individual images. So here I ask, what hand does the chef use to lift the pot at the start of the video? So this seems like extremely basic, but you actually need to know that he's lifting the pot and not already holding it to begin with, and obviously rooting that to the start of the video. So if we play this here, we'll see Gordon Ramsay is famously a lefty, but he actually lifts the pot with his right hand here at the very start. So that's what happens in this particular example. And you can see we get the output here, which is just plain text. And you could, of course, pass instructions to have the output formatted, but we give the equivalent API call as well too. But I just really wanted to illustrate that although this seems very mundane to humans, actually from like a video processing perspective, this is difficult to capture because you need nuanced understanding of the motion that's sort of occurring within the video. Some other really cool things that you can do are you can provide prompts to things like the chapters and highlights. So here I have two different examples. In this particular case, if you want to sort of fix the length of chapters or change the default length to something that's more consistent with the use case that you're working with, you can see here I'm requesting that we make chapters that are 30 seconds long. And so now Pegasus has fixed the chapters to 30 seconds in length for each of the chapters we've generated, except for this last chapter because the video ends at 3 minutes and 26 seconds. So these seem like small things, but they're actually quite powerful if you're trying to selectively pull out segments of a video and you need to fit those segments into a predefined time frame for some reason. Like if you're editing long form content down to short form content and you have a certain time window that you have to adhere to, these types of things can be incredibly useful. This is a much more fun example, but you can also say, give chapter titles that are rock songs and their artists that would fit the chapter based off of sort of what we're visually seeing here. So at the beginning here, right, we have this sort of, slow build up within sort of the car here. And so we're getting Stairway to Heaven, which is that really nice ambiance building before we get into more intense scenes within the video content, where we're getting things like Born to be Wild by Steppenwolf, which is significantly more energy. So this is like an example of some fun things that you can do, but are still rooted back to the visual understanding of the video itself. Probably my favorite example is this last one here, hence why I saved it for last. So we're actually going to combine a number of different things together here. So this is a scene from the TV show Scrubs. So this is actually a pretty iconic scene from that TV show, if any of you remember it. But essentially, we have the characters are JD and Elliot here, and they have like a history of a relationship together. And so this is a pretty pivotal scene where they're considering their life choices together and sort of what to do as individuals and as couples. And really what we want to ask here is, how does this video use visuals to emphasize the emotions that are trying to be portrayed over time, right? So we want to look at not just the visual elements, but we want to see sort of over time how those play into emphasizing the emotions that are supposed to come through from this video. So you can see that we get the sort of output here that is actually incredibly compelling and pretty consistent with what actually happens in the TV show. So we see that Pegasus is aware that, the close-up shots on the character's face are there to help emphasize the emotions that they're feeling. And we understand that their facial expressions sort of change from this more sort of casual demeanor to things like concern or distress as they start talking about the things that they're considering doing in their lives. And we even get on to talk about things like the lighting and the choice to show the characters laying in a bed together in their medical scrubs, where this is typically a professional environment, but it's sort of showing that they're in this intimate setting in a professional environment, which further enhances that emotional connection between the pair. And then we go on to also look at the dialogue to show how that actually the visuals are supported by the dialogue here at the end. So this is actually very compelling because it looks at how things are progressing over the course of the video to link back to this initial basic prompt question here. So these are just a few cool examples that you can, maybe play around with on your own. Obviously, upload your own content as well too. But the really fun part with the own prompt is it's very open-ended. You're not locked into a summary. You can have Pegasus generate virtually any output about the video content itself. So I think I'll probably stop there and leave 15 minutes or so for questions and the wrap up.
Awesome. Yeah, these are really creative and very each of the demo here I think showcase like a different part of the general API, right? From the standardized summarization description to different configuration you can make with your own prompt and the settings, right? So yeah, I think for us we hope our users can showcase your creativity and leverage some of these capabilities in your own video and yeah, get high quality text from using our API. Yeah, if you have any question from the audience, related to your your usage of our API, any more question about the model, etc. Or in general, like just what do you think about the kind of work that we're doing and like the potential use case that you can imagine?
A quick question. Do you think, is there a potential embedding endpoint for this as well? I'm also always thinking about my use case, which is very custom videos, niche videos in a specific segment, sports, etc., gaming. So I'm wondering if it's possible to somehow fine-tune Pegasus or provide some additional context to the model to improve the outputs.
Yeah, so we actually do have an embeddings API coming later this year. And since Pegasus is based on Marengo embedding space, right? Being able to fine tune Marengo embedding space helps with Pegasus output as well too. So we will also eventually later this year also be releasing a fine tune API. So both of those things will be available together in the cases where you have very domain specific content or terminology where sort of a nuanced fine tuning approach is required to get the most substantive sort of results that you may be looking for. But we are actively working on both of those things. And they should be available later this year.
Awesome. Thanks a lot.
Of course.
I have a quick question. Were those embeddings trained to optimize any specific task, or were they trained in essentially just an unsupervised way? And one of the reasons why I ask is when say something is an encoder trained to classify ImageNet classes, it can actually be very difficult to use that as a pre-trained model to build off of and fine tune when you have, say, objects that are not actually classes in ImageNet, because then you actually do have to do catastrophic forgetting intentionally. And so a lot of times it can be very beneficial if that is your use case, but if it's not, then just much more like unsupervised way of encoding these different data points that you get so that they're semantically similar in some way in some embedding space turns out to be a bit more useful for domain specific fine tuning that differs from the data that the pre-trained model was trained on.
Yeah, so I can provide an answer here, and then I think Minjoon or Ray, you guys can follow up with maybe more on the actual training side. So in general, right, we attempt to sort of encompass a broad data set without sort of any particular one direction for the type of thing that we're trying to train for, right? So not trying to optimize for like a particular type of content or particular type of output, but identifying where there are deficiencies in the data set for, say, something like question answering sort of formats and incorporating more of that into the training data set. Also having these sort of natural language descriptions rooted to general time codes allows Marengo, for example, to identify things that wouldn't necessarily be considered part of the training data set, which cascades down to Pegasus. So we've we've actually had our product manager before. We searched for something crazy and it found it, and she was like, "How does it know?" Because right, these are things that really aren't necessarily in the training data set, but by like compositional sort of concepts, you're able to either partially understand or at least direct the model with appropriate context in the case of Pegasus with prompting to be able to pull something out. That's not to say that, right, there's like coverage on 100% of tasks. Obviously, there are certain things that are generally speaking not currently possible. But Minjoon, do you sort of want to elaborate that more on the data set side and how you and the team approach that?
Yeah, that was a very, I think, good response. So I think it's just to add a point to that, just one little comment is that, so I think it's probably more accurate to say that how we design our training data is not to be comprehensive in terms of covering, like, say, every domain in the world. Of course, maybe that could be also beneficial, but that's like, I think, impossible because there's so many private data too, right? But then rather what we're trying to do is that we want to create the training data so that it's more of a, so that it can teach the model about the world. So the teaching about the world is not showing every possible permutations of situations. It's more about how you actually approach. Well, I mean, like in education, for instance, I think it's very similar to, I think, education, because we're not trying to actually make the model memorize everything. We want to induce the capabilities in the model. And if we could induce it better, then what we see is, as Travis said, sometimes some of the scenarios are not exactly in the training data, but then still the model is able to generalize and will actually handle that situation without much problem.
Yeah,
Cool,
for
thanks.
example, the example I showed with scrubs, right? The embedding model is not explicitly trained to, right? We're not explicitly feeding training data that captures human emotion or, you know, can transfer that to embedding space, but it's sort of like a consequence of training on a sort of varied enough data set with rich enough concepts that, as Minjoon said, isn't like 100% coverage of absolutely everything. But humans aren't really exposed to 100% of absolutely everything either, yet you're able to pull from the knowledge that you do have to at least infer or make a you know, a really good educated guess in situations that are unfamiliar to you. And most of the time, right, those guesses tend to be fairly good. And so that's what we've experienced and seen both with Marengo and as a result with Pegasus.
I see.
Hopefully that answers your question, and let us know if you guess you want more detail, but I was trying to not be overly specific as well.
No, I think it implicitly does. The point is, like, you're trying to give the model enough tools so that by it can one, identify, and then two, combine however many n concepts together in a way so that it can it's not hindered by like too strong of an inductive bias in any one particular direction during pre-training, and instead rather it can combine those different contexts, and especially when fine-tuned upon, much more rapidly be able to do, you know, the infinite space of tasks. You know, it's going to be infinite, actually. There's multiple infinites, but like it would be much more easily able to do that, and rapidly adapt towards doing that, rather than being inductively biased towards like a particular smaller subset of, say, like certain task specific stuff, which again, you know, that's not a bad thing. But it's just like when you get that very domain specific fine tuning, then it might be like very, very, very difficult if you've induced it strongly in a different direction. But it sounds
Yeah.
like from what you're saying, like that's not really the case, and kind of Minjoon also supported that, where it was like kind of, you know, teaching it a wide variety of stuff so that it can then with the model like come up with its, you know, use those contextualized representations and in a sense reason. I hate using that word now. Reason about multiple parts and put those together in a way that from the examples was actually pretty convincing.
Yeah, exactly. And I mean, humans do this all the time when they watch movies, like especially like sci-fi movies or something where there's like a new like technology or organism that obviously doesn't exist that you've never been exposed to before. But after watching the movie for like 5 minutes, you're immediately sort of familiar with the terminology and what the characters are referring to and what the general thing is that they're talking about is at a high level, all from pulling from the contextual information from the video plus the information that you've learned about already, right? So when Pegasus or Marengo are running, this is what happens as well too, especially with Pegasus, is it's obviously been trained on some amount of data beforehand. It's looking at the contextual information of the new video that it's actually having access to, plus the user prompt, which can provide additional context to make up indeficiencies, right? Like if it's never seen a unicorn before, but in the prompt you say, if you see a horse with a horn on its head, this thing is called a unicorn. So output that in the response when you're talking about that particular thing. That's sort of very similar to how humans operate. And I think the movie example is sort of the easiest way that we probably all experience that on a regular basis.
Yeah, cool. Appreciate the answers.
Great. Yeah, I think we have like 3 minutes left. Seems like, you know, there's a lot of engagement in terms of the details about the learning itself. So yeah, I hope, you know, this webinar did a great job of like educating, you know, the audience around the science, right, behind our technology and cool capabilities that you can use with it. Yeah, like in the scenario that there's no more question, I think we can just close out the webinar a bit early. Thanks, Ray and Minjoon for covering a lot of the technical question around the modeling around Pegasus, and Travis for you know, showcasing some of the practical demo of what you can actually accomplish on our shared API. And also, I think most of all, like appreciate all the great question from the audience, ranging from, you know, the science part to, you know, the more like, you know, application level use cases. And I think our main goals this year is to keep optimizing and producing more capabilities, both from modeling side, but also from the product side, to you know, build the best video foundation models in the market. So yeah, excited for you all to try it out and you know, give us a lot of feedback and iterate and yeah, help us grow the product and the company. Thanks everyone for attending, and hope you enjoy the rest of your weekend.
All right, thanks, James.
Thanks, everybody. Bye-bye.